And this is the last one here. Well, I want to show you that both in why experiences are so powerful. So I told you that genes are utilized early on to set the blueprint up to build the architecture, but it's experiences that mold that architecture. So what you're looking at is a heat map of the auditory system of an animal. And if you notice, there's a lot of red, there's a little yellow, and there's some blue. The heat map just represents different frequencies that the animal can hear at this age. Now, it says 16 days, that's kind of like a toddler for this animal. So their hearing map, what kinds of frequencies they hear, is not set. And you can see over the course of when they go through teenagehood, by the time they pop out on the other side, they've got a pretty well-defined map. Blue, yellow, and red is very well defined because they've been experiencing all different frequencies over this period of time. So look what happens if we do the experiment of just allowing those animals to hear one frequency. What do you think happens? Okay, there's that. There's that. So in a very short period of time, it transforms into a mature sensory animal where they can hear all different kinds of frequencies. This is what happens if they only get one frequency, right? The map never gets refined, it never gets precise, and in fact, it can't even hear some of those frequencies. So this is how early experience can have such a powerful impact on architecture. If you don't experience it early, you're not going to set up the architecture in a way where it's going to be able to detect it later on. So is this true? And you can think about the visual system. If we don't use both eyes, we don't develop binocular vision. It's that simple. If we only use one eye, the other eye's patched, the other eye is not going to be able to function. This is the same thing. But cognitive systems, learning systems, require the same kind of early experience. And I think the best example is studies that you probably know and are familiar with. If you look at the use of language, cumulative vocabulary over time, independent of socioeconomic status, the number of words that are used within the first 16 months, 0 to 16 months, is identical. It's thereafter when the child is going from recognizing phonemes, individual sounds, to putting them together to build over the vocabulary, recognizing the relationship between a word and an object that happens around that period of time. Look at how things take off. And it's simply correlated, not just SES, it's correlated with the complexity of language that's used in that household. There's a very direct correlation. So what they hear is what they're going to utilize to build their wiring, their circuits, that are going to allow them to communicate in more sophisticated ways. So like our sensory systems and our cognitive systems, our stress response systems are tuned during development as well. So here's always the legislator's favorite experiments that I'm going to describe. And maybe Jack Shankoff, who was here talking to the Smart Start folks in February, maybe talked about this. I just want the Smart Start folks to recognize that whatever neuroscience Jack Shankoff knows, it's because of me. Okay. There's some people who know Jack well, and this is going to get back to him, I'm sure. Okay, so there's a beautiful set of studies that was done by a group up in McGill University. And what they notice is that in their colony of rats, these are animals that they're using in everyday experiments, there were some moms that showed more time spending with their pups, licking and grooming them. That's how rats take care of their pups. They don't give them video games, they don't put them in front of the TV. They lick them and groom them, that's what they do. So we call those high care moms, and when you look at those pups as adults, how do they respond to stress? Well, there's their typical response. If you stress them a little bit, very mildly, you see that blue line, it goes up. That just means that their cortisol level goes up in the first 10 or 15 minutes of the stressor. It stays up for a little bit, and then it comes back down. That's a good thing. Up, stay up for a little bit, you got your energy to respond to the stressful situation, then you come back down. Now, in that rat colony, they noticed that there were other moms that did not spend nearly as much time with their pups. So they licked and groomed, but not nearly as much. And so when you look at those, there's the red line, That's the stress response of those pups when they're adults. Goes up higher, stays up longer. Does come down, but it's like you put your foot on the gas for a long enough period of time. How long is it going to take for that engine to eventually wear out? They're more hyper-reactive. They're more hyper-responsive when something happens to them stressful. They're more reactive in a negative way. Now, what's interesting about this is it has nothing to do with the genes that they inherited. It's not that the rats from the high care and the low care passed on different genes. And how do we know that? Well, they did a very smart experiment. They took the pups from the low care moms and they cross-fostered them to the high care moms. And what happened? When they become adults, their stress response system looks just like they were born from the high care moms. And when they have offspring, their offspring behave like they came from high care moms as well. So those early experiences of care and bonding and attachment, even in rodents, even in rats, is so important in terms of what's going to happen for a lifetime. Now remember, we're testing their ability to deal with stress when they're adults. So this happens for a short period of time in development, and then we wait till they're adults and we test them, and these are the kinds of differences that we're seeing. And we know, by the way, work has just come out looking at this in humans. So this is rats. The same thing happens in humans in terms of children who have been abused. We look at them as adults. Now, the reason why this lasts a lifetime is because of something, I think that's on the next slide. There we go. Why is it that it lasts a lifetime? Why doesn't it just reset itself? It's like a thermostat, right? Somebody walks in the room and turns it up, like my wife, and I go walk in the room and turn it down. She's got the blankets and I don't. That's why we moved to Los Angeles, actually. You don't need blankets. Why is it that it lasts a lifetime? This had perplexed scientists for a long time. I mean, how is it, what is it, soldered in there? Why doesn't it change? Well, it turns out it's kind of like solder, because what we know now is that there's a whole other way of affecting an individual that's different from the genes that they inherit. It's the experiences that actually change the chemistry of the DNA that they inherit. Is called epigenetics, and some of you may have heard about this. Epi just means above. It means that it wasn't inherited, but somehow those experiences are chemically changing the DNA permanently, or at least we haven't figured out how to reverse it. So in the case of stress response, it's changed the chemistry of a gene that's important in terms of how that individual is going to respond to stress. And that change is, like I said, it's a chemical change, and it seems to be a permanent change. We haven't quite figured out how to do that. But the work in rats now has been moved to humans, so we know that this is a conserved mechanism, happens across the board. Okay? And so this balancing act that I talked about before, the huge number of negative experiences that can happen for those who are most at risk end up creating a stress response system that's going to look like that. Very difficult to adapt under a whole variety of conditions. They just don't have the tools to be able to adapt because of the lack of those positive experiences and an overwhelming number of negative experiences. Now, look at this picture carefully. That's your brain. Well, not your brain. It's not even my brain. It's a brain. And what it shows you are the structures that are involved, parts of the brain that are involved in mediating fear and anxiety. Look carefully. Don't blink. You ready? Those are the parts of the brain that control memory and learning. Did you see anything change? The only thing that changed were the words, right? Because the same structures that get affected by early adverse experiences to drive fear and anxiety are also the same parts of the brain that are involved in learning and memory. So now you understand why you can't extract them from each other. They grow together, they develop together, they're integrated together. So if you want to affect learning in a positive way, social emotional development, giving children the tools to control fear and anxiety, those become part and parcel of good learning situations as well. And again, all of you in this room know that. This is news to legislators. And this is very powerful when they start thinking about why it is that these programs are so important and why they have to be, in a way, what I describe holistic. Focusing on one dimension is not how a child develops, and it's not how the brain develops either. How am I doing for time?